Hey, Sam here. I'm going to do another tech interview, mock tech interview today, where I'll try to solve a random Leetcode question. We're going to choose one at random, and let's just see what we get. If you've been on my channel before, this is a new interface. I'm actually using the IDE itself rather than trying to use a Google Doc. It's way more fun to use an IDE, so I've heard that Google and other companies have finally kind of got with the 21st century and are using using a basic code editor instead of GDocs or whatever. So I'm pretty happy to do that myself for these videos. So let's see what we got. Number 589, N-ary tree preorder traversal. All right, we got a preorder traversal type problem. So we're given the root of an N-ary tree, and if you haven't heard of an N-ary, it's like a binary, but it could be n children instead of just a 2 for binary. And return the preordered traversal of its nodes values. So input serialization is represented in the level order traversal. Each group of children is separated by the null value. Cool. So 1, 3, 2, 4, 5, 6, and we expect it to go 1, 3, 5, 6, 2, 4. So preorder, basically always the earliest child first. And here an example 2, I'd expect 1, 2, 3, 6, 7, yeah, and so on and so forth. And some of the questions we might have is, what do we do with an empty tree? Return an empty string or empty list. We're being given this class of node, and it'll have the value as well as its children. Children could be null or empty list, since this is a list of children. You could have 1 child, 2 children, 3 children, as it is here. N-ary. We know that the number of nodes in the tree can be no more than 10,000. These are some of the questions we would be asking in an interview. Let's try this the other way around. So questions are, will the tree fit in memory? And for Leetcode, yes. If no, we might approach this a different ways. Actually, the algorithm will be somewhat similar. Another question is like all valid inputs. In this case, for Leetcode, yes. If not, we need to do checks for null value, empty. Like if the root was empty, what do you do? How big could this tree be? Like how deep a tree? And in this case, they're giving us 1,000. So this actually does matter a little bit, because one of the possible solutions we could do, so let's just think about approaches. And up here. So one approach might be recursion. That's kind of the one we're most likely to do right now. Another is to do it iteratively, where we basically implement recursion with a stack or queue, I think, one of the two. And the advantage of this one is that, so first of all, recursion, easy to write, relatively easy to write, intuitive. That's the big one. And for problems like this, where it's usually in a tech interview, a intuitive solution is more than good enough for the interviewer, unless they ask for more. Iterative, you don't, the negative is you have to worry about stack overflow. So let's say the tree was, you know, 1 million children deep. If you're storing all of this information in the stack, that can overflow it, uses up the memory. Stack memory is different often from, oh, good question how Python implements it. Either way, important to keep in mind that sometimes you can use up the space if you're doing recursion. So iterative defines that memory directly or dynamically in a more understandable fashion. Harder to implement. Better for deep trees. What else is there? Can we do any sort of shortcuts? Not in this case. The tree doesn't seem to be sorted or anything special like that. Well, here's the follow-up. Recursive solution is trivial. Could you do it iteratively? Well, let's make sure I can do it recursively, first of all, because I'm not entirely sure I remember how to do that. So let's have a look and do recursive. I think it should be as simple as we're returning a list of integers. So let's just assume we're doing this preorder return self.value children first. So I think it's just self.preorder of of child, or child in root dot children. And then you return yourself at the end. So 135624, and the 1 comes first. So your own value. I think you can just do it kind of like that. This might be a one-liner. So if there was no children, this would be an empty list. It would just be the value itself. I think you can do it along these lines. Not entirely sure if I need to wrap this in a, like, so for example, output equals, root.val, and then you could output extend with this portion right here if you wanted to. That's another way you could approach it, but let's just see if this works as is first of all. And the idea here is you're doing every child after the root node. Okay, let's just check if I can do it like, I think you can add list, like merge them together this way. Oh, never mind. All right, let's do it the first way then. And I think you can use the generator as is. No, probably not. You have to turn it into a list. I think the mistake I'm making is can't use this as is. I think I need to create a subfunction to type node. It'll return. All right, why would I need a subfunction? We got the value, and I'd like to extend it for each child. Oh, but each of them will be a list. In fact, what I'd like to do is output that extend with for child in root.children. Let's just do it the direct way. Output.extend with that child's values. And once you have no children, you're just returning yourself. Yeah, that makes sense. Okay, good. To see it passes the test cases at least. If you had an empty children, you would just be returning this value by itself. You're always returning a list. Should be good. Let's have a look and submit and see how that does. Some non-tap has no attribute val, so we are allowed to have an initial input of empty. I misread the description. I just assumed that you wouldn't ever have a empty node passed in. So if not root, turn an empty list because there's nothing. In fact, I think we could do a test case right here. Create a new test case to try running that and seeing how that does. Good, empty, empty, submit. Cool, good to see. Right in the main group, nothing too special there. Could we do this iteratively now? That's the interesting one. I think so. So first of all, let's just talk about the recursive solution. We're going to be iterating through every node in the list for n nodes. Even though you're going through all the trees and stuff, it doesn't matter. You're only checking each node once at the end of it. So O of n time. In the worst case, you might have O of n space because you could have, say, one branch tree all the way down for n nodes, and you're storing n-1 stack space in memory, stack memory. That would be the worst case here. And also when you're building up your output. O of n, I don't think you can ever do better than that because you're always returning the output is the number of nodes. So n, O of n space is ideal. O of n time is also ideal because you have to check every single node. So let's see if we can turn this into a recursive, iterative approach. We're only about 9 minutes in. Oh, keep that going actually. We were 9 minutes in. Let's see if we can do it iteratively. And the way I'd like to do that is to keep a, it's either a stack or a queue. I think it's going to be a queue. You're going to push in, keep a queue, push children in as you go. And once you pop a node from the left, you'll push in through the left all of its children after adding that to the output. So let's try that. Hopefully me talking made some sense there. We'll see if we can go. And what we can do for queues is, for now we're just going to use let's use the DQ from collections import. DQ, I think is what it's called. And this just lets you get O of 1, gives O of 1 inserts pops from the left. Because a normal Python list, you could do it with the insert 0 in a 0 index and so on, but that becomes a O of n shuffle to recreate that list, I'm pretty sure. So let's just use DQ for now. So we'll start with our queue, let's call it Q. I'm having to write it every time. It will be a new DQ, and then Q dot append. Prepend, I think, is also to the left. Does Python give you prepend? That's a good question. Let's see, 1 second. I think prepend is a word. Or is it called append? It looks like it's called append left, actually. Yeah. These kind of like syntax is not important to about that there. The syntax is not super important when you're trying to do a mock interview. It's good to know the majority of it, but you know, edge cases like this, the interviewer will happily help you out or let you choose the word you want. So we're going to add our root node, and we know it's not null because we checked it up here. And while Q is not empty, we will Q.popLeft, I think is what it's called, and we'll create our output. Take our output and add the current value. It's just called val. Add all children to the left. And then Q.append left child or child. For child in current.children, append to the left. Actually, we need to keep the order of this the same. We might need to reverse the order of that. That feels a little ugly. What I'm trying to make sure here is when we add, let's say we have our root node is 1, and we have for each child we add to the left. We want to make sure 2 is the first one you look at. So we might be able to add it to the right. Then when you get more children, no, it has to be on the left. Yeah, so we might have to go backwards. I think we could clean this up afterwards, but let's just see where we're at right now. So we've appended that child to the left, and we just keep going. And once the queue is empty, because we've checked every single node, we return the output. And I think that might just be it. If this children is empty, does this fail? Empty list in reverse is totally fine, I think. Let's see. Not called append left. Oh, it's lowercase. Okay. Try that. And top left is also lowercase. All right, hold please. I think that should be all we need though. And the nice thing about this one now is all we're storing is O of n space. And we're doing a O of n time over each. Because we're only ever appending a node once. Try this. I think this should work. Yep, that looks good. And let's submit and see how we did. Cool. Ran a little slow here, which doesn't make me happy to see. It might be some optimizations, but also it might just be the backend that's running on the cloud, especially when these are simple questions. The variation of a couple milliseconds has all to do with a lot of extra things that are not just related to the algorithm, so I wouldn't stress too much about this. However, if there's like bimodal distribution or some really large variation on 100 milliseconds or more, then by all means, have a look for the extra edge, whatever optimization is missing. Happy to see we were able to get an iterative solution as well. I think it's good to be able to know how to turn something iterative, but often, especially for entry level and or even I'd say senior engineer questions, the question doesn't care so much about the iterative approach versus recursive. Recursive is totally valid. The problem will just be more complicated in other ways. In fact, it'll probably be complicated enough that you'll spend more time on that logic than you would on trying to convert it to iterative, but not always. Sometimes it might be, it's good to know regardless. Only thing I'm trying to think about here, and all these appends are O of 1. That's the key at value of a DQ. Creating this list is O of 1 for appending to the right. Trying to think of any nice optimizations here. I wonder about going through this in reverse. There might be a way to append to a queue or append left multiple values. Let's see. Extend left. Order is reversed as a result of left appends. No, it's still the same thing, I think, but might be a little bit faster, go one way. Anyway, I hope this was interesting to you all, and see you guys next time.